In this video, we will be learning how to solve sums of the type where you have to find the angle between the hour hand and minute hand of a clock at a given time. So let us say, for example, we talk of this particular diagram which simply represents a clock. What I need to initially know solving these kind of questions is that what would be the angle between any two consecutive numbers? See, the entire circle has been divided into a total of how many parts? 12 to 1 is like one part, 1 to 2 is like the second part, 2 to 3 is like the third part. So these are three parts. There are three more parts here, three more parts here, and three more parts here. The entire circle, if you count, has been divided into a total of 12 parts. Entire circle means it would correspond to an angle of 360 degrees. Being divided into a total of 12 parts would mean that every part would be of measure equal to 30 degrees. That is, the angle between any two numbers on a clock will be equal to 30 degrees. That is, if I make one line here and if I make one line here, the angle between the two of them will be 30 degrees. What if I make one line at the number 1 and the other line at the number 5? You will say that from 1 to 2, this much angle was 30, 2 to 3 it was another 30, 3 to 4 it was 30 more, and 4 to 5 it was 30 degrees more. So the total angle between the two numbers 1 and 5, that total angle will be 30 added 4 times, which would give you 120 degrees. Okay, so this is how you can find the angle between any two consecutive numbers on the clock. And now, say for example, let's talk only of the hour hand. Okay, think about it. What if I look at the clock when it is 2 o'clock? When it is 2 o'clock, the clock would look something like this. Let's focus only on the hour hand. The hour hand is specifically pointing at the number 2. Let's rub out the minute hand and just consider the hour hand, which I am drawing a little longer in this particular diagram. The hour hand is pointing exactly at the number 2. After 1 hour, what will be the timing? If now it is 2 o'clock, then after 1 hour it is going to be equal to 3 o'clock. I mean, the time is going to be 3 o'clock. So when it is 3 o'clock, the hour hand will be pointing at the number 3. So our conclusion is that in 1 hour, the hour hand is tracing an angle of 30 degrees. Why 30 degrees? Because the angle between any two consecutive numbers was equal to 30 degrees. So in 1 hour, the hour hand traverses or it traces an angle of 30 degrees. The question is, 1 hour is how many minutes? 1 hour would be 60 minutes. So in 60 minutes, the angle traced will be equal to 30 degrees. Now what if I ask you that how much is the angle traced in 10 minutes? Angle traced by the hour hand in 10 minutes. The hour hand was tracing an angle of 30 degrees in 60 minutes. Let us say that in 10 minutes the hour hand is tracing an angle of x degrees. You can just cross multiply over here and just say that 60 into x will be 30 into 10. You can simply solve for x and very easily you will get the value of x as 5 degrees. All those who are very quick with your calculations, you can do it in this way also, that 10 was basically 60 divided by 6. So the angle here will be 30 divided by 6, which would be equal to 5. What if I ask you how much is the angle traced in 15 minutes? So again you can take it as x. Use your cross multiplication method. So 60 into x would be 30 into 15. And you will have the value of x as, in this case it would be 30 by 4, which is 7.5 degrees. And the other method which I spoke of will also work. That is, this number was obtained by dividing 60 with 4. So if this angle was unknown, we will obtain this angle by dividing 30 with 4. So 30 divided by 4 would be 7.5, and that is why the angle here would be 7.5 degrees. What if I ask you the angle traced by the hour hand in 20 minutes? So 20 minutes is like 1/3 of 60. So the angle here will be 1/3 of 30, which is equal to 10 degrees. Okay. So that's how you can make some big and small calculations related to the clock problems. And if you're thorough with these calculations, we can straight away start taking our first question. So let's take a look at it. Here's where we have our first question. Find the angle between the hour hand and minute hand of the clock when the time is 10 past 11. 10 past 11 means 11:10. If 11:10 is the timing, the minute hand will be pointing exactly at 2 the R hand will not be at 11. It will be slightly somewhere between 11 and 12. Okay, so this is where you will find the R hand, and now you need this angle between the two arms that we have drawn, the R hand of the clock and the minute hand of the clock. Now, let's just check the angle between 11 and 2. 11 and 2, there is 1, 2 and 3 parts between 11 and 2, which is why we can say that the angle between 11 and 2 will be 30 into 3, which is equal to 90 degrees. Because the angle between two consecutive numbers was 30, we can say that the angle between 11 and 2 will be 30 plus 30 plus 30, which is equal to 90 degrees. But the R hand was not pointing exactly at 11. It was a slightly beyond 11. So we need to find the measure of this angle also. The measure of this angle will be subtracted from 90, and that is what will represent theta, that is the angle between R hand and minute hand in this particular case. How much would that angle be equal to? In 1 hour, we know that the R hand is going to travel an angle of 30 degrees, that is in 60 minutes. The R hand covers an angle of 30 degrees. In 10 minutes, the R hand will cover how much of an angle? The R hand will cover 30 upon 6, that is equal to 5 degrees. So the angle which we finally have between the R hand and minute hand in this case will be 90 minus that small part which was 5 degrees and 85 degrees. That is what will be the angle between the R hand and minute hand of the clock when the timing is 11:10. Let's take one more case. 20 past 7 means the timing is 7:20, and when the timing is 7:20, the R hand will be somewhere between 7 and 8. That is your R hand, and the minute hand will be exactly at 4. Okay, so how many numbers do you have in there? From 4 to 5 it will be 30 degrees, 5 to 6 30 more, 6 to 7 it will be 30 degrees more. So the angle between 4 and 7, that is 30 degrees into 3, which is equal to 90 degrees. But our angle in this particular case is not 90 degrees, it is a little more than 90, because this extra part is what we will have to add to 90, and that is what will give us the final angle between the hour hand and minute hand of the clock in this particular sum. Okay, so to identify how much that angle will be, we again go for the same thing, that in 1 hour the hour hand is going to travel an angle of 30 degrees, that is in 60 minutes the hour hand crosses 30 degrees. So this time in 20 minutes the hour hand is going to cover how much of an angle? 60 divided by 3 would give you 20. So the angle that will be traveled by the hour hand in 20 minutes, that would be 30 upon 3, which is equal to 10 degrees. Okay, so that 10 degrees we will add to 90. We have 100 degrees, and this is going to be the angle between the hour hand and minute hand when the timing is 7:20. Okay, let's take yet another question. 35 past 1, so the timing is 1:35. If we try to draw it on the diagram, 1:35 means the hour hand will be somewhere between 1 and 2, and the minute hand will be exactly at 7. So from 2 to 3, 3 to 4, 4 to 5, 5 to 6 and 6 to 7, we have how many? 1, 2, 3, 4, 5 parts. So the angle between 2 and 7, between 2 and 7 the angle is 30 into 5, which is equal to 150 degrees. But that is not our exact angle. In fact, I should have taken between 1 and 7. So between 1 and 7 the angle is, this time it will not be 5, it will be 6 parts, and that angle will be 180 degrees. Now this is the extra angle which the hour hand has travelled, and this extra angle needs to be subtracted from 180. That extra angle will be how much? In 60 minutes, that is in 1 hour, the hour hand is travelling 30 degrees. So in 35 minutes, how much will the hour hand travel? You can take that angle as x, just cross multiply, so you have 60x equal to 30 into 35. You can take that 60 in the denominator right here. So you have 30 cancelling of 60, you are having a 2 in the denominator, and x will be equal to 17.5. So in 35 minutes, the angle traveled will be 17.5 degrees, and that 17.5 we will subtract from 180. So the angle between the hour hand and minute hand when the time is 1:35 is going to be 180 minus 17.5, that is 162.5 degrees. Okay, so that's about the timing 1:35. Let's go ahead with one more example. Quarter to 6. Quarter to 6 means 5:45. So when the timing is 5:45, the hour hand will be somewhere between 5 and 6, and the minute hand will be at 9. Okay, so now from 5 to 6 it is 1, 2, 3 and 4 parts. So the angle between 5 and 6, that would be 4 into 30, and that is equal to 120 degrees. Now that is not the exact angle we wanted. We need to subtract this extra angle that we have calculated, and that extra angle will again be obtained in the same way like we have obtained it in the previous questions. In 60 minutes, the hour hand is traveling 30 degrees. So in how much? It's 45 minutes now. So in 45 minutes, the hour hand will travel 60 is like, it's 3/4. I mean, 45 is 3/4 of 60. So the angle will be 3/4 of 30. 3/4 of 30 is like 7.5 into 3, which is 22.5 degrees. If you have understood that calculation, fine. If not, you can take it as x degrees, cross multiply, and with that you will get your answer as 22.5 degrees. So this small tiny angle here is 22.5 degrees, which needs to be subtracted from 120, and that will give us this angle, which will turn out to be what? 120 minus 22.5, that is 97.5 degrees. So when the time is 5:45, 97.5 degrees is the angle between hour hand and minute hand of the clock. I have taken 2 more examples. Let's complete those examples quickly, and that will be the end of this video. So 2:20, when the timing is 2:20, the minute hand pointing exactly at 4, 2:20, so the hour hand will be somewhere between 2 and 3. We will take the angle between the marks 2, 3 and 3, 4, 2 parts, so that angle will be equal to 60 degree. When you point exactly at 2, it is basically this angle which was equal to 60 degrees, from which we need to eliminate this tiny angle. The timing is 2:20. So in 60 minutes, the hour hand was traveling or tracing an angle of 30 degrees. So in 20 minutes, the hour hand is going to trace an angle of 30 divided by 3, which is 10 degrees. So this tiny part out here is 10 degrees. And now the angle between the hour hand and minute hand, this angle, is going to be the entire 60 minus 10, which is equal to 50 degrees. So 50 degrees is the angle between hour and minute hand of the clock when the timing is 2:20. And finally, the last timing, the last example, 10:10. So 10:10 means 10:10, right? Yeah. So the minute hand pointing exactly at 2, the hour hand somewhere between 10 and 11. The entire angle from 10 up to 2, 10 to 2 would mean a total of 4 parts, and that is why the entire angle would be 120 degrees. So that's 4 into 30, which is 120 degrees. And this tiny angle out here, that tiny angle would be what? It's 10:10, right? In 60 minutes, the angle traced by the hour hand is 30 degrees. So in 10 minutes, the angle traced would be 30 upon 6, which is equal to 5 degrees. Again, for all those who are not able to get these calculations, you just take the value as x, cross multiply, and you will have the value of x. So we get it as 5 degrees. So that 5 degrees needs to be subtracted from that 120. You can visualize it from the diagram itself. And this entire angle would be 120 minus 5. That is 115 degrees. So this 115 degrees is the angle between hour and minute hand of the clock when the timing is 10:10. So I hope that with all these examples, you are very much clear with this particular type of questions where you had to calculate the angle between the hour and minute hand of a clock at a particular time. I hope this was helpful. Thank you for watching.